everyone. Thank you. Good afternoon and welcome. We're really super excited for you to be here. State Farm has been a huge supporter of the SciTech Institute for many years, and we've been really involved with supporting and mentoring the chief science officers as well. So what we're going to do here today is start off sharing a little bit about our careers, the path that kind of brought us to becoming software developers here at State Farm. Then we're going to open it up for some questions, let you ask us, sort of like an AMA. We do want you to ask us just about anything. So I'm one of the panelists, and I'm going to introduce my next panelist, but I'll go ahead and get started first. Hi, my name is Susan DiGennaro, and I am a software developer at State Farm, working as a public cloud advocate on the public cloud adoption team in our infrastructure area. My work is mostly focused right now on supporting and onboarding teams who want to move their apps or their data into the public cloud. That takes a lot, there's a lot involved with that. So we take that pretty seriously and make sure we get them set up and ready to go. I've been involved with that kind of technical training most of my career. I started out as a coder, but I recognized I really liked helping other people learn. This industry takes a lot out of you. You gotta actually keep up with stuff. So I loved watching people learn and helping them really be successful developers. So I mostly taught OO languages, tools, frameworks, things like that. I'd run classes at different companies. And now my work is all about the ins and outs of the cloud, trying to make sure that we reduce, mitigate, got rid of risks to putting your stuff in the cloud. Try to help others see those pitfalls so that they can code securely and all of their stuff goes seamlessly. So that's me. That's pretty much what I do. And I'm going to turn it over to my coworkers and let them talk a little bit about their careers and how they got to where they are today. Becca, why don't you go first?
Hi, my name is Becca Trost, and hi to the gecko. I have been with State Farm now for almost 7 years, I think. I started off in the Bloomington Normal area where State Farm originated, and I went to school in Bloomington at Illinois State University. I have a degree in computer systems technology. I am actually, I think the only one of us four that is not a software developer. I am an infrastructure analyst. I have experience in coding, and I have developed in the past, but that is not my background actually. And I'm glad I can talk because when people think of computers, they usually think of computer software, hardware, or they think of programming. I do a little bit of everything. So I've done scripting, I've done programming, but for the most part, I do a lot of systems admin work. The team I am currently working on is event management solutions. So when you think of event management, you might think of planning like a party, stuff like that. It's not the case. It's events as in IT and infrastructure and applications, stuff like that. Anything, computer systems, backgrounds. An event is anything that's a discernible, it causes an impact, positive or negative, and it's detected and traced, and it can go through multiple applications. My team is it's a centralized team that basically takes in all the different products that we currently use at State Farm to track and trace and monitor all the events that occur in infrastructure, applications, services between, say, AWS, where Susan works, or software applications, pretty much under any platform at State Farm. My team is monitoring and managing all those different, we're not managing all of them, but we are using our skill sets in development and systems administration, logging, alerting, to go through and identify where we are, basically where we have broken pieces, where there maybe isn't monitoring, we haven't put it there yet, we have monitoring that's duplicated across but basically the point of my job is to identify and basically build a strategy to give a better availability for State Farm and all of our applications, identify patterns, stuff like that. And kind of that's where I'm at with my work. Prior work to what I'm doing, I worked in on operations where I did a lot of support, and I think that really helped me get to where I am and being able to work with multiple teams across all sorts of applications, tooling, security, different pieces. So yeah.
Okay, thanks, Becca. We're gonna move on to James. James, if you could give us a little bit of your background, that'd be super.
Hey everyone, my name is James Rodriguez. I am a full stack software developer, technical architect, UI UX designer, and researcher. I've been with State Farm for almost 5 years now. My 5th year will be coming up in October. I currently work in our research and development department known as Red Labs. I've had the opportunity in Red Labs, so I'm on a horizontal team. So I get to interface with a lot of our other different concept domains that are researching upcoming technology, things like blockchain, autonomous vehicles. One thing in particular that we're working on is a new service that we're offering called Sundial. One of my skill sets in particular is helping teams to do user testing and early research to kind of understand what are some of the pain points that customers have in various areas, what are their needs, and how can we try to solve them outside of just insurance, right? Sundial is an example of one of those products that we've actually developed in that way. I also help teams build out different fidelity prototypes, so things from paper prototypes all the way to a full stack application that we can quickly take to customers to gain some understanding of how we can better design and provide solutions and products for customers. I also specialize in doing a lot of architecture, so looking at different infrastructure that we do on AWS. How can we build out these products and services both cheaply, efficiently, and performantly, and also quickly, right? So there's a lot of, in research and development work, we have to do things very, very, very rapidly. We have to be able to pivot. And so a lot of my task is also helping these teams architect those solutions out so that we can move with pace.
Okay, thanks, James. Ratcheting up the cool factor a little bit there with some of the really interesting things that he's been doing with blockchain and autonomous vehicles. I think that's amazing. I love that we have that part of our area. And then following him will be Stephen. Stephen, take it away.
All right. Hello, everybody. My name is Stephen White. I'm a software developer here at State Farm. Unlike other people, I kind of started my journey on a TI-84 calculator programming back in high school. I've left that out of every other conversation I've had about it, but it started as simple as a calculator. But I graduated from Northern Arizona University in 2019, got my baccalaureate degree in computer science with a minor in mathematics. I interned for State Farm in the summer of 2018. I actually interviewed with James Rodriguez. He was the one sitting on the other side of the table, so it's kind of cool to be here with him. And I work in enterprise customer relationship management. So unlike James, where he works in the research and development and try to find ways to, help other products and teams within State Farm, my customer is actually the agents. So we write software in ECRM, that's the acronym, there's lots of acronyms here, but we write software in enterprise customer relationship management for the agents. So all of the views that they see to keep track of their book of business, all of the policy and billings and claims, all of that stuff that comes through in this nice UI and a website called Salesforce that I help write code for. I write a lot of Java code day in, day out. I've been focusing a lot on automation and testing and continuous integration and stuff like that now. And I spent a decent chunk of my time writing JavaScript and building the UI for these agents. A lot of what I do is to make the agents' lives easier. In State Farm, there's a lot of different clicks to get to a lot of different things because we're a company that is like almost 100 years old at this point. So in an effort to modernize that, we got a whole bunch of us writing stuff for this platform in ECRM. So I've gone from a calculator to writing lots and lots and lots of Java code every day. So that's my brief spiel. I'll answer a lot more questions, I'm sure.
Thanks, James. Or sorry, thanks, Stephen.
It's all
It
good.
got me all worried, like off kilter, because wow, like I haven't seen one of those calculators in a while. I'm a little older than you are, so it's been a while. But that's fantastic. Thanks for your intro. What we'd love to do now is just to open it up for questions, if anyone has any questions. Otherwise, I have some questions for our panelists. So I'm not sure where the questions might be just yet. So in the meantime, what I'd love to do is just help out with the little bit more about what all of you guys do. What things do you do on a daily basis? You know, if somebody's going to take your job or want to take your job, want to have your job, or understand what options they have, maybe tell me a little bit, Stephen, for example, what do you do on your in your daily work?
For sure. In my daily work, so my routine generally starts off pretty much like anybody else's. You know, get into the office. I work early hours, so 6 a.m. to 2:15 p.m. That's the beauty of being able to work remotely, right? I can just get up out of bed and grab my laptop, check in all my emails, make sure that there's nothing critical going on. But from there, I'm working on it's complicated to describe, but writing Java code to synchronize all of the policy and billing information that's coming through State Farm, all of those bills that people are processing, and trying to kind of carry it from one destination all the way up into Salesforce. So a lot of my time and effort recently has been spent on building something from the ground up. We've had architects design this system, and it's been like years in the making of building just these diagrams, and they've handed it to us. And over the past couple of months, me and two other software developers, kind of a sub team within a team, are constantly communicating back and forth on a daily stand up. You know, what are our goals for today? What are some shortcomings that we've had in the past day? What are we trying to accomplish? If we need any help. And then for about a week at a time, we do 1 week sprints. And in that 1 week, we say, here are some stories. That's what we call them. I'd like to grab this story that's probably going to take me, you know, a couple of days to do. Go ahead and pull that down and see if I can get it done by myself over the course of that week. Come back and the next week and say, okay, I'm ready to take on some new work, or that didn't really work out. We're an agile company at this point, so if that didn't really work, what can I try to do a little bit differently in this week? And all of those small 1 week sprints kind of build up for us to complete what is known as an epic, right? We've got this big system that we're trying to build from the ground up. We can't do it overnight. So 1 week at a time, slowly building this stuff, testing it. A huge part of my job is testing, right? Anybody can write software, but it takes a lot of attention to detail to make a system bulletproof. You know, we don't want things breaking in production because that impacts our customers, our agents, very dramatically. So that is what a lot of my day is spent doing, communicating back and forth between my little sub team within a team, and going through this regimen of Scrum that we call it, to accomplish the greater goals in a nutshell.
Yeah, thanks for all of that. That explains a lot about what we as a company try to do and how we try to always make ourselves a little bit better, right? Always find ways to improve. That's awesome. Thank you we do have some questions in here. First of all, do any of you work on technical projects outside of work? James is
Yep.
nodding. Go ahead, you can take this one.
Yeah, I can take that. So I didn't mention this in my introduction, but I actually have 2 bachelor's degrees, so a degree in computer science and a degree in business management. So I actually I have my own side companies. A lot of my side companies deal with software related solutions. So a lot of my technical projects that I work on outside of work involve sometimes just learning. I want to learn new languages. React was something I was particularly interested in. AI and machine learning were also fascinating to me. So that's time that I spend outside of work kind of learning these new technologies. And some of it bleeds into my work at State Farm too, right? I can take these same learnings and apply them to new projects in different areas, finding ways to refactor them. But a lot of my own passion projects are things and problems that I'm trying to solve for myself. So yeah, if I'm not coding at work, I'm probably coding at home. So I do a lot of coding during the day.
That's great, James. And you actually brought up a good point, right? As you continue to grow as a software developer, or as even just anybody who's technical, actually getting to apply what you're learning is the easiest way to learn, right? Teaching somebody else, even if that somebody else is kind of yourself while you're trying to build something. So I know a lot of us do that. I see Becca actually outside of work a lot, and we've been working on some other things ourselves. So let's see. Next question is, what advice would you give your 14-year-old self? Anybody want this one?
I can take this one. So for me, looking back on a 14-year-old self, you aspire a lot to do things, but you might have some fear of failure, fear of judgment from other people. You know, it's really easy to get caught up in the world of what's cool, right? And you know, if I wasn't very athletic in high school or when I was 14, but I would have pursued STEM a little bit sooner. I know that some barrier to entry for most people, whenever they think STEM, they think a lot of math, and they're like, I'm not a math person. And I'm here to tell you, you don't have to be the math genius of the world, but what you need to be comfortable with is the feeling of failure and overcoming that failure. You're going to fail at no matter what it is that you try the first time. You know, a couple of times when you learned to ride a bicycle, it didn't happen overnight. It took a couple of falls to do that. And similarly, I would encourage all of you that are thinking about STEM to not focus so much on something that you see as like the problem, like, oh, math is my weak point, but I want to code. I just don't want to do this. So because of that fear, I'm not going to touch it. I would say, you know, feel comfortable feeling uncomfortable, and you'll thank yourself as you go about it. If you don't succeed, you know, try again. If math is your shortcoming and you got the wrong answer, get a new piece of paper, try it again. Maybe you don't like paper. Maybe you like writing on a whiteboard. That was something for me that it took a long time to discover, that paper is constraining. I wanted to learn something, but I wanted to learn it and be able to step back and see it all from a distance. So that same type of logic you can apply to anything that you want to learn, whether it's music, whether it's math, whether it's computer science. So don't let that fear prevent you from starting, because once you start, you're going to start asking yourself more questions. How does this work? And then you'll start to investigate that, and you'll go on your own little path. And next thing you know, you're a programmer.
Oh, that's great, Stephen. And it's a great point to make that, you know, so many of us aren't exactly doing what we thought we'd be doing. And so don't let fear hold you back, because I can guarantee that there's plenty of other people who you are even working with who are still struggling to figure it all out, right? Every time that they encounter something new, it's new. So everybody started at the beginning some point. So next question is, I'm going to make Becca answer, because since she's been not talking too much, it's what's the favorite part of your job?
My favorite part of my job, actually, I love my job, but one of my favorite parts of my job is that the people, honestly, I love all the people that I work with, but it's the mindset when you're in a group, when you're with a group of people that have a very similar mindset to you. It's so motivating. And I feel like in IT, you really have to be in that mindset to enjoy it. And when you're around those people, I don't know, it motivates me more. I worked in 2 spaces that were very collaborative. I know it's some jobs in IT, it's a lot of individual work. You'll work with other people sometimes, or, like they discuss their sprints and working through people from that perspective. But I worked in 2 spaces. One was a support space where we would have outages and we'd have to constantly be working back and forth with everybody the entire time and kind of be on the same wavelength in a way. But I feel communication and being able to talk with people, which switching to remote for the last few months has been a bit hard from that perspective, but you adjust and you change. We have our regular sprints every 2 weeks, but then we have daily meetups, just constant communication, and you have to be I feel very good with communication to work in this field, being able to relay what work you've done, what work you don't understand, what you want to learn, to kind of go back a little bit on what Stephen and Susan both just said. I myself, to like the 14-year-old myself, I wish I would have started sooner, because as I graduated high school, I didn't think college was so much for me at the time. So I took some time off, and I didn't actually go back to college until I was in my early 20s. And then I went back, I finished my bachelor's degree, and then went and started work. And I right away actually started working for State Farm. So by just finding what you like and what you like about that job and getting yourself in a position that you enjoy because of what you surround yourself with, I think it's super important. And I mean, especially with State Farm, the people is a big thing for me. So.
Thank you. That was awesome. It's good to see. Yeah, and actually, I'm going to take the next question. The next question is there a lot of collaboration between each of your positions, or is it mostly individual? And each of us already talked about the teams that we work on. We all are on a team. We all are part of a larger area, usually in a team. But I've had the great opportunity to work in 4 different areas already within State Farm. Like there's all of these different responsibilities and all of these different areas within State Farm, and they work together all of the time. Right now, I'm in a position where, as I mentioned in the beginning, where my responsibility is getting people ready to move their stuff into the cloud. That means the entire enterprise. That means everybody. So I am constantly interacting with and collaborating with billing and payments and the people who support the agents like Stephen, and labs when they bring something into production like James. And when our stuff unfortunately goes down, that Becca helps with, and just making sure everything runs smoothly. There's a lot of interaction. Just in my short time, I've been at State Farm for about 5 years, and just in my short time, I've worked with so many different people in all of our different locations. We have location in Atlanta and in Dallas, Texas, as well as Illinois, and we all collaborate all of the time. Even with this COVID thing and everybody being at home, we're always talking to each other and building teams and building software, and really just it. And like Becca said, I love the people that I work with. They're all so, fun, and they really try hard to make everybody else comfortable and help everybody else learn and help everybody else succeed. And that's a lot of what we're all about here. Okay, so I have a new one. What could a high school student start doing? Because both Stephen and Becca mentioned, starting earlier. So what could a high school student start doing to learn to prepare for this kind of career? And who wants to jump in at first? I got my own ideas, but I'll let you go. Go ahead,
I'll throw in a little bit just because I have some experience with that.
Yeah, I think Becca wants to shoot in too when you get a chance.
For sure. I would say look for opportunities to embrace that logical side of yourself. And that's kind of how I ended up hopping in on this calculator thing, right? I was, we say this all the time, that computer scientists, programmers, we are the laziest people on earth because we build things that do stuff for us so we don't have to do it. And that's how I really ended up getting involved. I was in some higher level math, some AP calculus or something like that. Or physics is a perfect example of a class. And there were a lot of formulas. And I was like, this is a lot of stuff to memorize. I wonder if I could program my calculator to just put in the numbers and then have it output the answer. And then of course, my teachers were like, you can't just put down an answer. So then I was like, well, I wonder if I can make it output all of the steps as well. And it's seems kind of hacky to it, but all the teachers, when students complained, they're like, why is Stephen allowed to do that? And the teacher was like, did you do that? No, you can go ahead and grab a calculator, learn how to do it. And it was just super small like that. I wasn't on the computer programming mobile apps or, getting super in the weeds about it. I was just, I used what I had on hand. And then, like I said, it leads from one thing to the next. And then if you kind of get a flavor of it and you're like, I really like thinking like in statements like this, like if this, do that, then, you can maybe start watching some YouTube videos to learn about what other programming languages exist and just learn about the field in general. And if it interests you, then find a simple problem that you can apply it to, whether that's a calculator, whether that's maybe making a web page. You know, nobody has to see it. Doesn't have to be perfect, because we all start somewhere. But that's my advice. Just find little bits where you can let your logical side shine, or your UI side shine. If you're creative and you like to draw things, web development is also a really, really good option for you.
Becca, did you have something to add to that?
Yeah, I pretty much will piggyback off of all of that. Myself, I was very young, and I was really into hardware at first. I would take things apart when I was younger, stuff I shouldn't be taking apart that probably could have hurt me. So, but I would take things apart and then just put it back together. And then showing my age, when MySpace was around, I would love to play with my page and learn how to, I basically kind of taught myself some basic coding through that. And then in school, though, what I would highly recommend, especially if you go to bigger schools, because I know they offer a lot more coursework. I went to a small town school, and we didn't have programming classes other than web design. But honestly, when you're picking your courses, if you're allowed to like pick coursework, and you're interested in STEM classes like computer science, anything like that, just say that and see what classes are available to you. Because I was I think a junior in high school, and I didn't know that my school offered Cisco and a Cisco class, and then a hardware and software class. And I wish I would have known sooner, because I would have probably planned out my schedule as a junior and senior in high school and taken more coursework that aligned to what I was interested in. I didn't know it was available to me. So, I mean, when you're young, just start. I mean, we worked with guidance counselors, we worked with different coaches in high school, and if you think you're interested, just see if there's anything available to you in your classes. So.
Thanks. Thank you for that. I appreciate all of that. Hopefully that gave everyone some good ideas to start with. I will say for myself, I was fortunate enough to have a parent who was very involved in all of that. And we had a computer at home a long time ago, when people didn't have that kind of thing. And my mom took a Fortran class at the local community college. So I thought that was amazing. And so I started reading her book, and yeah, if any of you even know what Fortran is, that's old school stuff. So just seeing other people interested in knowing that there were community college classes out there for me to take, and things for me to do on my off time. But now it's a lot easier. Like Stephen mentioned, you can go out on YouTube and find some ways to play around and do that as well. So we have another question. What do you think about learning basic coding from things like bolts and spheros? James?
Yeah, I can take this one.
Okay.
So thanks for bringing that question up. I think it's a great opportunity to kind of see the bridge between hardware and coding. If you have access to robotics clubs, that's a great way to also get introduced into the technology industry as well. You get to see kind of both sides of technology there, right? Both in being able to do programming, as well as potentially building out some hardware to make things do what you want them to do, right? A lot of the particular instance of Spheros and the bolts have a really great way to learn how to do programming. Very great user interface. You can even use your mobile phone to actually do, I think it's called block coding. So you can kind of drag and drop different block elements and kind of make it do what you want to without having to really dig deep into all the structures of programming. Another thing I'd also recommend potentially is Scratch, which is another programming tool that you can use to kind of get introduced to programming using block language. Both of those are great ways to just kind of get introduced to the overall different kind of statements and how to make things do what you want them to do.
So I'm going to ask you to follow up a little bit about that, because there is another question about, well, what are some programs that students can add to their laptops their computers at home to begin doing that kind of coding? Do they need to download things? And do you have any preferences?
That is a good question. There are websites, like I mentioned, Scratch, where you can code in the browser. You don't actually have to download anything. Those are great ways to kind of get started. And I think there are other websites too, like W3 Schools, which is another great resource for learning, which has embedded coding where literally you can learn something, try it out in the browser, see how it works, fiddle with it a little bit. Freecodecamp.org is another great resource as well. Thank you, Stephen. And I think a lot of it depends on how advanced you want to start getting, right? We have this notion of an IDE, which is how you want to start doing different developing languages. So if you're wanting to go more advanced beyond just using things in the browser, you can use things like Spring Tool Suite, something that I use professionally a lot. Atom and is a really great resource as well. Notepad++. There's Visual Studio Code. So they're all things you can get started if you want to do more advanced programming. Stephen, I don't know if you wanted to share some other resources yourself.
Yeah, so I came across, it used to be called codefights.com, but I just posted in there, it's called CodeSignal. And CodeSignal is super, super awesome for learning how to program and think programmatically, because you don't need to install anything on your computer. And software development usually has a lot of, okay, what do you mean I need a Python version or an environment variable, all of that stuff. So I would encourage, check out codesignal.com. You create an account, and then what it is, basically, you can pick whatever programming language you want to program in on the web page, and it will present you a problem and say like, hey, here's a problem statement that says we want, given two numbers, we want to get the result of adding those together. Can you write that in here? And then they have little tests that are built in. And then your job is to, okay, choose a language and then just write code in your web browser and then click run tests. And then it'll say if it passes all of the tests. And if it passes and you click submit, you get 100 coins. Cool. And you move on to the next challenge. You can also, they'll have like challenges between you and other software developers. So say me and James create an account, we can have a friends list, I can invite him, and then we can do a code challenge together. And then maybe it's like 5 minutes, and then there are 3 separate problems, and we're competing against one another to see how quickly we can solve these problems. And it kind of makes it fun. And some of them aren't super complicated, but then you get into the other half of it, which they teach you about concepts like data structures and algorithms and trees and things like that you might not get, or like actively search out on your own, but you might get handed in a textbook. They give it to you in practice. So if you want to learn more about arrays, then there's an entire section on arrays that are problems that just deal with arrays. And you can choose whatever language you want to do it in. If you want to do it in JavaScript, cool. Say I figure out how to do it in JavaScript, and I'm like, I want to see if I can do this in C or C++. Then I can switch it over real quickly and see if I can solve the same problem in a different language. That kind of will help you build, some of this rapport with yourself and say, okay, I can sample this language and see how I like to solve problems. Or if someone might try C and go, oh, this is a little bit too in the weeds. I don't know if I want to do that. Let me see if I like JavaScript. And then if you like it, then you can solve problems in that language, and you're having fun doing it. You're getting rewarded doing it. And you're more likely to continue to solve problems that way, and then try to figure out what else you can do with that language. So I really recommend codesignal.com, W3 Schools as well. That's great for learning UI, HTML stuff. And then I posted Free Code Camp as well. That Free Code Camp, I think it's less interactive, but there are lessons. So if you learn or you want to learn about a specific thing, you can probably go to Free Code Camp and say, teach me about arrays or vectors or things like that, and you can. So definitely check out CodeSignal.
Awesome. Thanks, Stephen. And actually, that is a perfect segue to our next question, because I was even going to say that there are a lot of different languages out there, and you don't have to pick one necessarily from the get-go. People ask all the time, how many languages do you know? And I can say, I know about 20, not to speak them, but to code them. So I know, yeah, I've started a long time ago with JCL, COBOL, C, C++, C Sharp, Java, Python. Yeah, I've got a ton, and JavaScript. So what's the reason I can say I know all these languages, and is mostly because I can rely on Google, and because there are a lot of similarities between coding languages. Everybody's got a while loop, everybody's got a branching statement, everybody has a way to separate your coding. There's a way to do that in every language just about. So what you really need to know are how to solve problems, not necessarily the language itself. Because like Stephen just said, you could go into these websites and into these learning programs and test it out in different ways. Test out JavaScript, test out Java, test out C Sharp, and see which one you actually like. Because once you know one of the languages, then it makes it easier to learn the next one, because you're just solving the problem in a different way. It's not really that you have to be, singularly a Java person or singularly a Python person. You'll be able to solve the problems elsewhere. And that's where Google comes in. As one of you guys said already, programmers are very lazy, right? We look for easy ways to solve problems. We never start from scratch, because we don't have to. We can help each other out. We leverage code from other places. We look at on Stack Overflow for suggestions or issues that we're running into. The developer community is wide, it is large, it is very supportive, and we help each other out all the time. So as far as the similarities and differences are, there's a lot. The differences are usually small, just syntax things, or that some languages have different limitations on what they can and can't do. But a lot of times, one's just specialized. HTML, CSS, JavaScript is more front end kind of stuff. Java, C Sharp, C++, those are more back end usually, but it doesn't mean they can't cross over a little bit. It all depends on what you're trying to do. That's why we know all of these languages, all these different languages. So, oh, we have a new question. So State Farm is an insurance company. Yeah, I know it sounds boring, but it's really not, I promise. Why do they have such a large number of software developers and infrastructure analysts and all of these different people to support an insurance company? Anybody want to give it a shot?
Can I?
Sure.
Just, can you hear me? Okay. So I will say, prior to my work where I'm at now, I worked in storage management. State Farm, yes, is an insurance company, but if you break down what we produce, yes, we produce a service, but the only real tangible thing that State Farm produces, if you think about it, is data. We produce a lot of data, and we have to do a lot with that data, whether it be analyze it, use it for marketing, anything like that. But we need ways to actually, you need ways to bring in the data, you need ways to export the data, you need ways to use the data. And we have lots of, we have one of the biggest, we had one of the biggest private networks for a company regarding us compared to some other companies. And that takes a lot of people, a lot of support. State Farm has, we used to have a bank, we no longer have a bank, but all the different areas and components, we need lots of technology to support that. Claims, we're able to get a claim in and out so quickly because of a lot of it has to do with our IT department. We have great support, but we also have great technology at State Farm. And we are not a technology company, but we have a very good foundation of technology at State Farm. We've touched a lot of different technologies, and I don't think we're scared to try different things. Some stuff has come and gone, but I don't know. If anybody else wants to elaborate a little bit more, that's just my thought. I know State Farm, we are a large company. We are all across the United States. And yes, we do sell insurance, but again, we sell a lot of insurance. We dip into a lot of different areas, and we need technology to support those areas. So
Awesome. That was great. Thank you so much, Becca. I'll just add a little bit to that. You know, we are the largest auto insurance company in the country. We sell more policies than anybody else, but we also sell homeowners policies and we also sell life insurance policies. We have all of these different areas. So we have all of these different customers to support in all these different ways. And we want to be as responsive as we possibly can to those customers. We're all about, you know, the customer, supporting them. So having all of these different software developers and analysts to make sure we're running our business as best as we can to support our customers, to support our agents, to support all of the data that Becca was just talking about. It involves a lot. So yeah, there's a lot of us, and I think we work really well together. We're doing well. All right. So somebody kind of took over here, Jeremy.
Oh yes, that's Dr. Jeremy Babender. He is the creator of the Arizona SciTech Festival. He's the executive director at SciTech Institute. I think he wanted to join to say thank you and a shout out to State Farm for supporting all of the initiatives that we're doing over here at SciTech. So Jeremy, take it away.
All right, can you hear me?
Yes, we can.
And I'll be quick because I had to change rooms, so I have like a lot going on with the kids balancing it out. But really appreciate what State Farm has done. I think the cool part is that I think people often don't recognize how much of an IT company really State Farm is and how it drives everything that happens. And so like we are so fortunate to be part of that effort to really inform people about what really technology careers are, and places like State Farm need that, and really are lucky to have State Farm in Arizona really taking advantage of what we can build in Arizona. So thank you for doing this. We appreciate you being part of this festival and the panel and really helping to make these things happen.
Well, we're very happy to be here, Jeremy. Thank you for inviting us. We love to talk about the work that we're doing and kind of the interesting things that people don't think about when you think about insurance, right? I mean, James was just talking about all the great stuff that he's doing with blockchain and with autonomous vehicles and really interesting coding opportunities and forward-thinking future opportunities. James, was there anything else you're working on that you want to share with everybody?
See here, yeah. So we a lot of different concepts that we're kind of working through. Drone technology, I think, is an interesting one that we've been kind of working through. Well, after I forget which hurricane it was, but we're actually able to send out some drones to kind of analyze some of the aftermath of the hurricane. And you know, you can imagine it's pretty dangerous to actually send out agents to go, you know, see damage in certain areas. So we actually were able to leverage drone technology to see homes that were impacted, and because of that, be able to give out claims much faster. That's just one example of some of the things that we're doing here. The Sundial project I mentioned earlier, which is kind of my main project that I'm working on right now, especially in, you know, the state of a pandemic. You know, it's difficult for families to help each other, especially seniors who are aging in place. You know, it's potentially riskier to visit some people. So Sundial is a product that we have now where we're trying to bridge some of that gap, right? Being able to have your center and people who care about you want to be connected with you. And that's not an insurance product, right? So State Farm is not just insurance. We're looking at other ways to provide value and to be a good neighbor.
Thanks for that. We really appreciate that. Let's see, where are we on time? Oh, we have time for a couple more questions if anybody has some. Oh, wait, I think I have one. So how does the future look in your field? Well, that's a loaded question. I can take that, or somebody else. Does one of you guys want to pipe in?
I'll chip in, see if I'm relatively new to this field, so but I will say that take a look at the world around you, and there is not a single business that exists now that isn't in some way, shape, or form using technology. So the further that we get into the future, the more and more dependent we are going to become on this technology. And I think that that Becca said that, you know, we have a lot of data, and that technology, I think data really is the future of where technology is going. Data by itself doesn't really mean anything, but when it's aggregated, it means everything, right? You can break down a person based off of, what color shirt did they buy? How many shirts did they buy in their life? What type of food did they buy? Like all of that stuff. So as we get more and more into the future, I see companies in artificial intelligence, machine learning, deep learning, those core concepts are really going to be what kind of ushers us into the next era of automation. Nobody knows how to optimize itself better than a machine, right? We just give it the tools to learn itself, and we feed it the data, and those models are really what's going to be they carry business decisions today. You see people build charts with data, all of that stuff. So aside from, the nitty gritty of, oh, I write in Java, I write in JavaScript, I do Python, just keep that in mind, that maybe moving forward, you might want to take a statistics class, even just to have a basic understanding of what probability is. That type of stuff is really where we are headed, and you will have a huge leg up if you can even speak in the briefest of, or the smallest context on that. So
know what an algorithm means.
Yeah, an algorithm. Cooking
know
is
what
just
an algorithm means. Right? Yes. You can't do one step without the previous step. So
correct.
Great. No, that helps a lot. For me, as far as the future goes, or at least thinking about, what does the future look like in my field, I don't think about that too often, because all the time in this field, if you would have asked me 5 years ago what I'd be doing now, I wouldn't even have been close. And if you asked me 10 years ago, what would I have been doing 5 years from now at that point, I wouldn't have been close. So it's more about keeping your options open and knowing that there's going to be new things to learn and new things to discover and new chances to take. And I have to say, giving State Farm a big little thumbs up that they're trying new things. We keep trying new opportunities, ways to be more efficient, ways to leverage new opportunities, new code. Like I said, my area is all about the public cloud. Everybody hears about things in the cloud and what's the cloud all about. And we're leveraging that on a wider scale for this huge insurance company. We're taking advantage of that new opportunity to save some money, be better responsive to our customers in the industry. So, and giving, indirectly gives all of us the opportunity to use new technology and new opportunities, new ways of doing things. So, oh, Jeremy's asking, is it true that State Farm is the largest user of Salesforce? I actually used to be in AMCC but Stephen is now, and that's his deal. So I'll let him take the credit.
So just after seeing that, I went ahead and Googled companies that are using customer relationship management using Salesforce, and Spotify is up there, Amazon Web Services, US Bank, Toyota, Macy's, T-Mobile, Aldo, and the New York Post. So take that as you will. There are a ton of companies that use Salesforce. I personally didn't even know what Salesforce was until I was thrown into my job and they said, you're going to be writing software for Salesforce. And I was like, cool, what's that? Apparently it's a multi-billion-dollar industry. So I will say that State Farm is one of many large companies that utilize Salesforce's customer relationship management, because that's exactly what we need. We need to be able to manage our customers and our customer base. And in this case, it's like trickle down. My customer is the agent, but for every agent, maybe there's 50 to 100 people that they service. So how do we keep track of that? We use one centralized platform, and Salesforce is pretty good at providing all of the stuff that we could need to interface with that data and give agents the tools that they need to use. So I won't say we're the largest user, but I'll say that we're one of the larger users.
Well put, Stephen. Good job. And very balanced, politically correct. So we're getting close to time. We still have quite a few minutes left, but I want to give each of my panelists, including myself, the opportunity to kind of leave you off with some words of wisdom, some final thoughts. And when we were asked to do this, I started thinking about that myself, like what would be my last thing I want you to remember walking away from here? And it is, hey, if you love to solve problems and name things, this is the job for you. Because that's what I spend most of my day doing, especially as an actual coder. I have to name things. I have to name my programs. I have to name all my variables. I have to name the systems that everybody else is going to be interacting with. And I'm really all about solving the problems. But what I'd really like to make sure you know is that if you're going to do this kind of job, whether it's an infrastructure analyst or a developer or an engineer or any of this kind of technology, you gotta like to learn, you gotta like to read, you gotta like to try new things, because what we're doing is changing every day and you have to be comfortable with that. So those are my words of wisdom. I'm gonna let Becca go next.
Okay. Yeah, to go off of that, you will be a lifelong learner if you are in work with computers. Everything's changing. Sometimes, like, I mean, I know when in school, I didn't understand the point of getting books in school, because within 6 months, those books were obsolete, depending on the versioning of whatever you're working with. But two things I would like to reiterate was, one thing, to go back on, like job stability, stuff like that, or just if you feel like you want to change. That's why I love IT, because there's so much, and it's not just like developer space. Susan had mentioned the different areas that she's worked at or worked in with State Farm, and just knowing her, I know her other jobs in the past, and it's just being in IT, your ability to transition from job to job or area to area, whenever, hey, this isn't really what you're feeling anymore, there's always opportunities in so many different spaces. And I say not just developer, because one thing I was very interested in and did a lot in school was networking. So Cisco, stuff like that, little pieces of learning how different components connect, not like networking with people, but networking with servers, understanding what an IP address is, little things that if you're interested more in connecting things, that's a really good field to get into. Cybersecurity, also a huge, everybody needs security. State Farm has a huge security team. They're very good at what they do. Another great field to get into. And when it comes to computers, there's so much to them. You can be so specialized in IT and computer science. I won't say it's like as close as being specialized as like in the medical field, but the medical field, you could be very specialized. You could do the exact same thing in IT, whether it's with computers, coding, networking, anything. So I like what I do, because I love the ability to change almost at any point in time if I want. So.
Thanks, Becca. James, you wanna impart some wisdom on us, please?
Yeah, so I mean, outside of being a lifelong learner, I think it's important to take advantage of your youthfulness. You have a lot of opportunity to explore and learn about different career opportunities for you, different fields within STEM, especially in the age of information and technology. You guys have access to so much content out there that's produced for free on YouTube and all these other various learning sites. Taking advantage of these opportunities like this, just to go out there and learn, see what's actually out there, see what pokes your interest, and that's going to help you find what you're going to be passionate about and you love to do, and may that be a guide for your future career choices, right? Find something that you just love, so that it doesn't feel like work, right? I love what I do. I love going to work and solving problems, and one of my biggest things I would say is just find something that you love.
Thanks, James. Yeah, it is. My dad used to say, if you find something that you love, you'll never work a day in your life. I don't believe him, by the way, because there are days where it definitely feels like I'm working, but I still enjoy my job. I still like what I do. I still never going to like what I do every single second of every day, but dang, it's a good job. Steven, you want to go ahead?
Sure. I would say two major things come to mind that will stick with you, hopefully. One is that Rome wasn't built in a day, right? You don't have to be perfect at anything that you try immediately. It's going to take time. And two, if you haven't heard of this phrase, we stand on the shoulders of giants, right? everybody that you might think that somebody knows a whole lot, but guess what? That person didn't get where they are today by just, reading or whatever. They had to ask questions. They learned from the people that went before them. And, we're in a really, really awesome state in the world where we have all of this cool stuff that we're learning, and you're in the transition period where later down the line, you get to, maybe be the next person that, creates the next blockchain or whatever. You don't know what you know until you know it. So my final piece of advice would be, do not be afraid to be the person in a classroom that asks questions. So many times I've been in a classroom where a teacher asks, do you get it? And then the people that are too uncomfortable to say they don't get it, they just struggle through it. And then they decide that I hate this topic, I'm never going to touch it again. Don't be that person. Ask a question. If you don't understand, ask 10 more questions. And if it gets to a point where they say, talk to me after class, then you talk to them after class. If you don't feel comfortable in the middle of a class, talk to them after class. I attribute everything that I know to a lot of people answering a lot of silly questions. So be the person that stands out and asks a silly question, because I promise you that you will go a lot farther that way than just sitting in silence.
And that is a wonderful way to end our session here today, because truly we all rely on each other for a lot of things. None of us is as smart as all of us, right? The reason we work on teams is so that we can rely on each other's strengths and try to help each other with our weaknesses. You're never going to know everything, so got to be comfortable with asking. And I love the people that I work with because they are comfortable with me asking, and it's great to see. So thank you all for joining us today.